All right, let's dive right into this explainer. We're here to hack your O-Level and IGCSE Computer Science paper 2210 seriously. If you're looking to bag full marks on automated systems, you are in the exact right place. We're going to look at this whole thing through your lens, the student sitting in the exam hall, and we're using actual examiner reports and killer study notes to figure out exactly what the graders are dying to see on your paper.
So here's our tactical game plan. 1. We're cracking the examiner's code. 2. The automated system trio. 3. The perfect feedback loop. 4. Avoiding common exam traps. And 5. A pros and cons masterclass.
All right, kicking things off with Section 1, cracking the examiner's code and figuring out what they really want.
We're going straight to the source for this, the principal examiner reports. And you know what's super interesting here is the massive emphasis on two specific things, technical terminology and context. I mean, the examiners are practically begging you to ditch the vague, everyday language. Like, if they give you a question about a car factory, your answer actually has to talk about that car factory. Generic answers that could literally apply to anything? Yeah, those are going to score you as 0. You've got to speak their language.
Picture this. You sit down, you grab your pen, and you fill out that candidate details box, trying to ignore how fast your heart is beating, right? Well, that is the exact moment you need to shift your mindset. You aren't just writing about computers anymore. You are proving to the examiner that you've got this highly specific technical vocabulary locked down. Every single time you write an answer, just ask yourself, am I using the actual technical terms? And am I linking this directly to the scenario they gave me?
Moving on to Section 2, the automated system trio. Basically the hardware holy trinity.
First up in our trio, we have sensors. Now, the absolute crucial point you need to hammer home in your exam is that sensors measure physical properties. We're talking temperature, pressure, light levels, and they output analog data. But here's the catch. Computers do not understand analog data. So, to lock in those marks, you absolutely must mention that this analog data goes through an analog to digital converter, an ADC, before it can be processed. Don't forget the ADC.
Next is the microprocessor. This is the brain of the whole automated system. It receives that digitized data from the sensor, but listen up because this is the phrase that literally pays on the exam. You have to mention that the microprocessor compares the incoming data to preset values stored in its memory. It doesn't just casually look at the data, it actively evaluates it against a specific parameter to figure out if it needs to do something.
And finally, we have actuators. These are your output devices. So when the microprocessor decides, hey, we need to take action, it fires off an electrical signal to the actuator, which then converts that signal into actual physical mechanical movement. This might be firing up a pump, spinning a motor, or snapping a valve shut. Oh, and quick tip, if the microprocessor signal is digital, you might need to drop in that it passes through a digital to analog converter, or DAC. Keep that in your back pocket.
Okay, Section 3, the perfect feedback loop. This is how you secure your operational marks.
Let's see how our hardware trio actually builds into a continuous feedback loop. If a question ever asks you to describe how an automated system works, do not panic. Just follow this exact 5-step logic. Step 1, sensors continuously sample data. Step 2, an ADC converts it to digital format for the microprocessor. Step 3, the microprocessor compares this data to preset values. Step 4, if the data falls outside the acceptable range, a signal gets sent to the actuator to take physical action. And Step 5, the whole process continuously repeats. Literally, if you just memorize these exact 5 steps and write them out in order, you're practically guaranteed full marks on any system interaction question. It's like a cheat code.
All right, Section 4, avoiding common exam traps. Let's get into some master tutor tips.
You know, even students who really know their stuff end up throwing away marks because they fall into this one specific trap, year after year. It's wild. The biggest misconception we see? A lot of students write that sensors send signals to actuators. Like they genuinely think a temperature sensor just directly turns on a heater. No way. They absolutely do not. Sensors only send data to the microprocessor. The microprocessor is the one analyzing the data and sending the actual instructions to the actuators.
Let's put these side by side. Look at the answer on the left versus the one on the right. The first one says, sensors send signals directly to the actuators. Bam, 0 marks. It completely bypasses the brain of the system. But check out the highly technical correct answer on the right and makes it crystal clear. The sensor sends data to the microprocessor. Then the microprocessor compares it to stored values. And then the microprocessor sends the instruction to the actuator. The microprocessor has to be your middleman every single time.
Which brings us to Section 5, Pros and Cons Masterclass. Let's nail down those contextual marks.
Remember a minute ago when we said context is everything? Well, consider this your ultimate cheat sheet for applying that. The exam might ask you to break down the pros and cons of automated systems in completely different fields, like manufacturing, agriculture, or transport. Please, whatever you do, don't just say it's faster. If the context is industrial, point out that it's way safer for humans in hazardous zones, but flip it and mention the constant threat of cyber attacks as a disadvantage. For agriculture, you could highlight the hyper-efficient use of water for irrigation, but balance that against the huge headache of needing specialist technicians way out in remote areas. Or transport. Think cruise control. Sure, it massively improves fuel efficiency, but dirty or faulty sensors can cause really dangerous malfunctions. Context is the absolute key to unlocking those marks.
Let's throw another context into the mix, medicine. If your exam scenario involves automated medical systems, we're talking precision robotic surgery or automated blood sampling, you can absolutely cite enhanced precision and smaller incisions as a massive advantage. Plus, it's way safer for the doctors if a patient happens to be highly infectious. But you've got to give a contextual downside too, right? So mention the astronomical setup cost for all that hardware, the need for super expert servicing, and of course, losing that critical human element in patient care.
And what if they throw domestic automation at you? Stuff like robot vacuum cleaners or smart home setups. For the benefits, focus heavily on how it frees up the user's personal time and the sheer convenience of controlling the whole shebang remotely from an app on your phone. For the drawbacks, keep it grounded in the physical reality of a house, short battery life, or how the system just completely fails at navigating weird obstacles like a sock left on the floor or getting jammed in tight corners.
So, bringing it all together. By using that exact, highly technical terminology, making sure you always name-drop the ADC and the microprocessor comparing data to preset values, and firmly rooting your pros and cons in the specific context of the question, you are totally equipped to hack this paper and pull in top marks. So what do you say? Are you ready to open up a past paper and apply this perfect technical feedback loop right now? I highly challenge you to put this strategy to the test today. Good luck!